So hi everyone, I'm Robin, CTO here at Load Impact. So I'm going to talk today about some opinions and beliefs that have formed over the last couple of years working in this industry, the performance testing industry, and at Load Impact as a company, and before that as a consultant in this industry. And the core belief is that developers should be load testing more than they do today. And I will explain a bit why, and I will demo also how. But before I do that, I want to start off by setting the stage with some history and also a quick run-through of what load testing is. But before I do that, can we have a quick raise of hands? How many people in here have done any sort of load testing before? Oh my God! Wow. That's way more than I thought. Okay, good. Good. So I've worked with this company for the past 10 years. And the company itself has been in the industry for, I think, around 15 years or so. And I remember when I started, we did consulting, so this was before Load Impact existed as a service and company. And we did a lot of consulting for larger companies, larger enterprises and government agencies. So we had people sitting at NASDAQ, OMX. We did projects for European Space Agency, and we've done a lot of work for .SE, the government agency, I guess, that runs the .SE domain and other things. So in those days, the companies doing load testing were mostly the large enterprises because they had the mission-critical systems that needed load testing, and they also had the wallets to pay for the quite expensive load testing tools back in those days, and also the consultants like us that came with the tools. But since the growth, the internet has kind of progressed, more companies have become dependent on the internet. So they have a lot of software systems that are mission critical for the business. So the interest for load testing has kind of grown as more and more businesses have moved to the internet. So naturally then the performance, the interest in performance has also grown with that. And a part of that spurred kind of the moment, the movement of web performance. And in web performance there's a golden rule, a performance golden rule that says that 80 to 90% of end user response time is spent in the front end. So you should start any performance optimization efforts there. And when this has been heavily evangelized, both through talks and presentations, and also tools like web page tests, Google PageSpeed, and Wiselo. And these are tools that usually give you quite a detailed breakdown of how how the client fetches resources from the backend systems, and then how the client, the browser, usually renders these pages, and then they often give you very actionable advice on how you can optimize your performance based on best practices. So the performance golden rule is it's a good starting point, but it assumes that the backend serving the resources, that its performance stays constant, so that it responds this equally well when you have one user or when you have 1,000 users. And that is very often not the case. So this is usually what happens when a backend system sees traffic outside of the tested traffic volumes. So the front end part of the response time stays constant, because the client and the browser never has to deal with more than one user in concurrency. So even if you have 1,000 users, they each have a browser. So the concurrency in the client is always one. But the backend system has to deal with all the clients. So usually what happens, if you haven't tested, usually your backend system can't deal with that traffic. So the relationship between the front end and the backend switches or flips. And so this is the problem that load testing is meant to help kind of mitigate and solve. Is that you can actually pre-production use load testing to test and make sure that your backend systems are capable of dealing with the traffic volumes that you are expecting in your production systems. And there are many, many tools that are available in the market to help you with this. Here's just a short, or a few of them. They're both open source and commercial offerings. And even though there's many different tools available, there's basically one for every language that's ever been invented. There's still a lot of people, and especially developers, that don't load test. So why is that? So a few common reasons that we hear are these. The first one is that we have very little traffic to our system, so that we don't feel that it's necessary for us to load test. And to that, I would say that even if you have 100 users or 1 million users, you still want to make sure that when you release new code, that the code you're releasing doesn't have performance regressions, because the user experience are going to affect people, no matter if you have a very, very high volume traffic or if you have small volume traffic. So you can gain a lot of value even though you have small volumes of traffic in production. And the second most common reason that we hear is that, well, I use an APM product, I use New Relic or AppDynamics or something else. And APM products are very good. They're very good at helping analyzing performance problems. But the thing with APM products is that they can only tell you things about the traffic that it sees. So it can only tell you things about the traffic that you send through your system. So you can't see what happens if you gain 20% more traffic or double the traffic, because it doesn't know. Some tools, they try to help you by extrapolating from the data it has, but you will only know if you can actually handle that traffic if you test pre-production with load testing. The third reason is the reason that I think is the most common one, that load testing is still too difficult, too complex, too time-consuming. There is too little value gained from actually spending the time learning the tools, learning how to do this. So why then should developers load test? Back to the core belief. Well, I think it's quite simple, really. I mean, like other types of testing, the developers, they know the application code they write, they know how the system works. They are the ones that have to fix the system oftentimes when problems appear. So it's more natural that you catch the issues early, so as far left as possible, rather than catching them in QA or operations, and you want to catch them pre-production. So the reasons are more or less the same as any other type of testing. You want to catch it early. The problem, though, is that a lot of the tools available on the market, they don't fit with how developers work in their modern environment. So a lot of the tools are they were either written for the QA or performance engineering professionals that used to do load testing back in the day, or they are geared towards developers, but they are very, very simple. So they help you get up and running with some simple case, but they fail to scale with you as you become more advanced and become, have more complex needs for your testing. So we think there's a gap in the market. So what do we think developers need? Well, there are three core beliefs here as well. We believe developers need good tool ergonomics. We believe that the tool should support simple goal-oriented testing. And I'll go through each of these in more detail. And the last belief is that the tool should support automation, have good automation support. so that you can run it continuously and catch performance regressions before they reach production. So good ergonomics, what does that mean? So we believe that the test cases should be written using code, both because of you want the power and the flexibility, but you also want to be able to version control your test cases like other types of tests. The tool should run locally, so it shouldn't be like our service, for example, have been SaaS-only service. We believe developers need a tool to run in their local environment, to run on the command line, and the command line should have very, very good UX, similar to modern tools like Docker and the whole suite of tools from HashiCorp. And it should run on all modern platforms used by developers, so Linux, Mac, Windows. And lastly, we believe that tools should be open source and have good documentation. And we have a strong belief that a simple test is better than no test. Because complexity is usually a function of realism. So if you go for perfection, you aim for too much realism from the start, you risk basically getting burned out from load testing. There's a larger risk that you are not going to do any testing at all because you feel it's too much work to get into it. So we evangelize starting small, starting with what we refer to as like a unit load test. So you start writing a load test for like one API endpoint, and then for another, and once you have a few, you can stitch them together into a larger, more complex scenario to simulate real user flows in how a real user or client would use your API, for example. And the tool should be optimized for this case. So it should be optimized for the simple test case, but it should also help you kind of scale and advance your testing and as you become more complex. And the last kind of major belief is that the tool should support goal-oriented testing and automation. So you should be able to write, specify goals that pass or fail the test. So you can signal to like a CI environment that a test has passed or failed. And that's very important because we believe that tests should be run continuously, automated, and for that you need to be able to tell whatever it is that triggers the run, whether the test has passed or failed. And this concludes the kind of presentation portion of this. Now I'm going to do a demo of how you can get started with this. But before that, do we have any questions so far from anyone?
Can you share the presentation later?
Yes, I believe the presentation will be shared. Yes, and there's going to be a GitHub repository that goes along with this also, the demo. Do you have another question?
I think the demo will probably prove the point. But you say you want to do unit tests and then stitch them together to scenarios.
Yep.
Unit tests are sort of they have no state, and when you have a scenario, you need a state. It's sort of it's a contradiction there. But I guess the demo will show exactly what you mean. So.
Well, we'll see if the demo clarifies something. Otherwise, we can get back to the question afterwards. Yeah. So the demo will have kind of three components. I don't know if you can see this, but there's going to be a target system, and the target system is going to be our testing site, test.loadinput.com. There's going to be a load testing tool, and load testing tool is going to be K6. We're going to use a CI environment, and I'm going to use CircleCI for that because CircleCI is the environment that we use here internally at Load Impact. Is there anyone else using CircleCI? One other person? Okay. What are you other people using? Jenkins or?
TeamCity.
Team
Services.
Team Services, Microsoft, yeah. So let's see, let's switch quickly to the So this is the test site. It's super simple. It's just very, very plain, simple HTML, an image, and a style sheet. Although the styling is not very sophisticated. So it's a very, very simple system site. K6, which we're going to get into now, is it's an open source load testing tool. It's built by us. It's written in Go, and you script it in JavaScript. So the demo is now going to be a lot of JavaScript writing and running K6. and then switching to the CI environment. So while I'm doing the demo, if you have any questions regarding the code you see or the output you see, feel free to ask them, as the question pops up in your head, because I think it might make for a more interesting demo than just hearing me and seeing me code. Yes?
Why Go plus JavaScript?
Why Go? So the gentleman over here is writing a blog article about those decisions. You can answer quickly if you want to.
Go, we looked for a language that was popular, had momentum, that was that you could be productive in, not as slow moving as C can tend to be. Go just fit the bill in those areas. It's popular, it's coming, and it's good. It has good concurrency support. It's fast. It compiles on several different platforms, and several things made us choose Go. But I'm writing a whole blog article about it actually. So it's and then JavaScript, very big language. Almost everyone, gets to use JavaScript a little bit now and then. So almost everyone knows a little bit of JavaScript. So it's like a common denominator almost. And we were worried that it wouldn't perform well enough for our application, but in the end it did. So we had to change JavaScript engines a couple of times.
Which engine in the end?
Sorry?
Which engine are you using?
We're using an engine called Goya now. So we use another one called Otto. So they're Golang JavaScript implementations.
Yes. Is this readable? I hope it's readable to everyone in the back as well.
I think you can make it even smaller actually. So you
can make it smaller? Yeah. That's still fine. No, it's a little bit behind the screen. Yeah. Is that okay still? Good. Okay, so we'll start here. This is the kind of the simplest script you can write for K6. Imports an HTTP module to get access to HTTP functionality. It has a main function, and it makes a GET request to the test system. So I should mention this is ES6 JavaScript. So I think it's the 2015 version of JavaScript. So it has some more things than what comes with the browser out of the box. So let's run this. Script.js.
Progress bar doesn't look so.
I'm wondering if I have.
Is it too small?
Yeah, it's probably too small.
Yeah, I'm thinking you're running a lot of them, but maybe that's just me.
No, I think the screen may be too small.
Yeah. You should put the
I'm
font a
wondering
little bit
if I
smaller.
have.
You zoom out a bit more.
Yeah, zoom up.
Oh yeah. Let's try this again and see what's this now.
Like
Yes.
Ah, there we go. Okay. I thought it might be that I lost network connectivity or something. Okay. Is that still readable?
Yeah.
Yeah. It's in touchscreen. Good. So this was a very simple script. When you run K6 like this, it will run the script with one user, which you can think of as a thread of execution, and runs through the script once, so one iteration. So that's what it says down here. Iteration 1, and it made one request. So you also made information here. You saw the progress bar, and this is some summary statistics. Not so interesting now, since we only made one request, so a lot of the values here are just like the same. So and I should mention also that you can tell K6 to output all the metrics. This is just a summary. So all the metrics can be all the raw metrics can be output to an InfluxDB database that you can hook up Grafana or something else to and graph all the metrics. You can output all the data as JSON, or you can opt to send it up to Load Impact to our commercial service where you can also visualize this data. That's called Load Impact Insights. Let's turn this into a load test now, so more concurrency. So for that, we need to add some options. So I'm gonna do a lot of coding, so there's gonna be small mistakes and stuff, but you just have to bear with me. So K6 has this concept of stages, which is basically how the number of users ramps up and down. So you can have as many steps as you want, and you specify a duration, like so, let's take something small, and then you specify a target number of users, let's say 10, and then you can have as many of these as you want. And you can leave off the targets if you want to, which means it will just stay at that plateau level, and then you can ramp back down. So this basically means you'll have a ramp up of users going from 1 to 10 for 5 seconds, stay flat at 10 users for 5 seconds, and then ramp down to 0 users for 5 seconds, so 15 seconds in total. Oop, that's something.
And 10 means?
10 means users.
Virtual.
So basically concurrent
Connections.
threads of execution running this script. Or it's not really threads, but you can think of it as threads running concurrently.
Maybe you should mention also the default function executes again and again and again.
Yes.
Virtual user executes.
Yeah. So yeah, exactly. So each user for the duration of the test, it will run through the script in a loop. So when the script ends, it will start over.
Can you
This
do
is more than 10 users, because 10 users clicking like this.
Yeah, this will, if I would leave it, it would be 10 users doing very, very fast
They put
clicking.
a binder on the F5 button.
Yes. Yeah, exactly.
Can you define the clicks per minute or something like that?
Clicks per minute. No, but you can. No, so there's no way to kind of pace the users like that. So what you use is, I'm gonna add now, like a sleep. So where you say, for example, as a user, if you visit the website, a user to your site would either read some content, stay idle, or whatever. I mean, this is stuff that will appear in your analytics, like how long they spend on a page. So usually when you write a script like this, you say, go to this page, then sleep or think or idle for X number of seconds or minutes, and and then you get a certain pacing of users. So I'll just use something small here, 3 seconds. Otherwise we just bombard the system with requests. And again. So now we can see in the way down at the bottom of the screen, we can see it says 15 seconds now, because that's the total duration of the test. So we'll just, so it's ramping up, staying flat, and then going down to 0 users, collecting more data. So we made a total of 28 requests now, and the max number of users were 10. So we can see that we have some more kind of spread in the data. Good. So since this is a load test, and or it's a test really, we want to make sure also that the requests are successful. And in a load test, there's more or less 2 dimensions to this. There's both the functional one. You want to make sure that the request has properly executed, in the sense that you get a 200 response back, or whatever is the successful response code. And you also want to make sure that the contents of the requests are containing the right things. And then there's the non-functional aspect of it, which is did the requests come back in a timely fashion. So we have those 2 dimensions that we want to kind of make sure are in line with our expectations, with our goals. So I'll go through the first one, which is the functional one. So K6 has a concept of checks, and a check is basically the same as an assert, with some difference. So an assert in like a unit testing framework, with halt execution and scream loudly that something happened. A check is different. A check won't stop the execution. It will just record the result of the test you're making, the Boolean result of the test you're making. So we create like a map or dictionary or object, whatever you want to call it. Is status 200. Lambda function, as dependency status equals 200. And another one that says, for example, this body size 1170, body. Good. Let's run this again. Or actually, before I do that, I'm going to remove some of these stages. You don't have to wait for 15 seconds every time I execute this script. So let's run it again. So now it's just running for 5 seconds and ramping up to 10 users. And then it's halting. Boom. So now I see there's some more in the output here. So we have our two checks. One of them succeeded with a 100% success rate. So all the requests went through okay with the 200 code response code. But the check looking at the body size is obviously wrong. It failed 100% of the time. So I'll go back and fix that. It should be 1176. So if we run it again. We can see that now it's all correct. So let's have a look at the non-functional aspect of this. So to clarify the difference some more between checks and thresholds.
Sound effects.
So the difference between a check and a threshold is that a threshold has the power or the authority to fail a test. A check is only records the Boolean true or false result of the check it did, but a threshold can fail the execution of a test. And that means in the case of case 6 that case 6 would exit with a non-zero exit code. I mean the command line application would exit with a non-zero status code. So let's add some thresholds to this simple script here. Thresholds. And thresholds, they act on metrics. So we can go back here and we can, for example, copy this metric. You add it, and then you specify one or more thresholds here. And thresholds are basically simple or small JavaScript snippets. So we have a %file function, for example. So you can say, I want to make sure that the 95th percentile stays below, say, let's say something, 10 milliseconds.
Is millisecond the default?
Yes, so the number you specify there, the default, yes, it's milliseconds. Yeah. So if we run this again, there's going to be a lot of back and forth in the script and the command line like this. Yeah. So now we can see there's a red X next to this metric, which means that the threshold has failed. So if we look at the 95th percentile, I believe it's this row, it's 78. So it's above 10 milliseconds. And yes, thank you. And here we can see this is just because of how my shell looks like, but here's the exit code. So you can see it's 99. So it's a non-zero. So if you run this in like a CI environment, this will trigger a failed build step. So let's change this to something else. Let's say this would be very generous, 500 milliseconds. Here we are. Boom, and we get a green check mark. So now we are good to go. So now we have some checks. We have a threshold. If we want to elevate checks to have the same power as a threshold, meaning you could use your checks to fail a test, you have to use a custom metric. So in case 6, there's a bunch of different metrics types that you can define. 6 metrics. Now to create the metric, let's say check failure rate. Check failure rate. Something like that. And the check function returns true or false. So if all the checks pass successfully, it returns true. If any of the checks fail, it returns false. So what we can do here is add a conditional. So if it fails, we add 1 to our rate metric. And then we use the metric name, comma, to set up a threshold. And now we say that we want the rate to be below. This is something I learned very recently. It's supposed to be decimal. So 1 is 100%. So this would say that the failure rate should stay below 10%. That's what this says. So let's let's introduce the same failure as before. Let's run this again. Boom. And now we can see that this metric has been added to the list, and we can see that it failed 100% of the time because one of the checks in that container or data structure failed. So it failed this rate metric for the threshold that we had set up. So that was about 10%, obviously. Let's go back and make this pass again.
Can you have just one rate metric or?
No, you can have as many thresholds as you want, and you can set up as many custom metrics as you want.
Okay, but the check failure rate rates less than 0.1. It doesn't reference the name check failure rate neither.
That name.
Okay.
Yeah, exactly. So it uses the name. Yeah, this name that I define here.
On variable.
Yeah.
It's a little bit confusing. I agree.
Yeah. Yeah, exactly. So I mean, I could have called them the same, for example. It's up to the user how to call them. So this is basically the foundation you would need to take this to a CI environment. We have some goals set up in the form of thresholds that can act on the results and pass or fail this test. But before we move to CircleCI and put this through that environment, I want to show some other functionality that exists in K6 that can help out as you progress from a simple test towards a more advanced test. And the first functionality I want to show is called groups. So groups is a mechanism basically for grouping requests and logic together. Groups. So you name your groups. So let's name this page. And then you have a function. Let's make this a little bit smaller. Boom. Close it. And groups will also structure the output a little bit different. You'll see that shortly, both on the command line and you can use groups in for example Grafana or Load Impact Insights to structure the results. And groups can also be nested, so you can have several groups. So for example, this test system has a few static resources too. So you could, for example, add a group that says static assets, like this. And now I'm going to cheat a little bit. So I'm going to hand code this. Boom. So I'm going to add the style sheet for this system, and I'm going to add the logo. And I'm using another function here of the HTTP module, which is the batch call. And the difference is that if you use the batch function, you can have several requests being made concurrently in parallel. So that's the difference. And then I make sure I have a check to check the status code of each of these requests. So let's run this now. 5 seconds away. Boom, boom, boom. I might have lost connectivity because all the requests failed. Yeah.
I can show the groups.
Yeah, but I can show the groups nonetheless. Yeah. So the difference is now that we have groups, you can see the results. I don't know if you can see it, but the results are indented. So you have the front page, and then you have the checks underneath the front page group, and then the static assets are a little bit indented as it's a subgroup, and then the checks underneath that.
I have a question.
Yes,
Is
please.
it possible to have more verbose error messages? So, for example, it said the status code is not 200.
Yes.
Is it possible to say, okay, it was actually this?
Yes, so you can, so K6 won't automatically output more verbose stuff, but you can use so the same API that exists in the browser. You can do like console log press status, for example. This would print the status code of the request. And you can log whatever you want, so you could print, for example, the full response body, for example. Yes, connectivity is back. So now you can see it. Yes, question, please.
Is it possible to both fake a start cookie to initiate a session and then receive the cookies back and then use them for continuing calls, so you lock it to a session and things like that?
Yes, to just be to safeguard my answer a little bit. The goal is to have full cookie flexibility. I don't believe we are entirely there yet. I think you can access cookies. You can see cookies that are attached to responses. I don't believe you can set cookies with a nice API. You can set cookies, I think, with through headers. So you can specify custom headers with each request. So you could basically do it now, what you're asking for, but it will be nicer. So you'll have clean APIs to do it, basically. The next functionality that helps as your script grows larger is tags. So many things in a script can be tagged, and that can help you, for example, when you save data in InfluxDB, or if you send them to our service, you can use tags to help filter your data, because a load test, if you run it for an extended period of time or for many users, it can generate a lot of data. So it can help if you have tags to kind of filter on things. So, for example, in this case, I could add tags to the static requests being made here. Static asset. Yes. So besides being nice for filtering results, you can also use tags to make more precise thresholds. So let's make a threshold specifically for the static assets. We're doing like this. So within the brackets here, we can say static assets, yes. So this means that the threshold will only look at response times from requests being made to requests tagged with static assets, and where the value is yes. So then you can set a different status code for these requests, for example. So you can say, for example, or a different threshold. So 100 milliseconds, for example. 90. Good. And I should also mention that there are some like implicit or included tags. So all HTTP requests, they have like status code and request method and the URL as kind of implicit tags. So you can use those as well to kind of filter or make more precise thresholds. Let's run this again. Boom. So now we'll see that the metric here has been duplicated, and specifically with this tag, and then you see the corresponding response time. So you can see that the 90th is 4 milliseconds long, so that's way lower than what I specified. So that's good. And the last functionality I want to mention in terms of organizing larger, more complex scripts is the one of modules. So K6 supports importing not only kind of included libraries that comes with K6, you can also split apart your load test into several JavaScript files and then import your files. So you could, as I mentioned previously, you could start out making, for example, like this. This is basically a test against a specific page. So if I have more pages, I could put each page into its own JavaScript file. So I could run load tests against each page, but then I could import those JavaScript files and combine them to create a larger flow of how a user would kind of browse my site. I'm not going to do that though, because it would, I think you've seen enough of me coding. So let's take this, what we have now, and let's move it to the CI environment. So a brief intro to CircleCI.
Just a quick question first.
Yes, please.
Referring back to my initial question. When you had a stage, I mean, you had a logged in user.
Yep.
With a session, probably cookie session. Can you handle that sort of, I mean, you could set headers, you could set cookies, but couldn't you actually make sure that there are different users, different logging users? So you have sort of an array of users logging into your system, and can you see?
Yes, so
they keep different sessions, different sort of state, track the state of each.
Yes, so each user that's simulated by K6 has its own context, so its own JavaScript context, and it gets its own cookies and its own HTTP connections. So it's separate per user. And the cookie handling is automatic by default. So if you have a response setting a cookie, and then you have a subsequent request going out to the same matching host and path and everything, the cookie will be sent. Yeah.
And they also have an ID. The views.
They
have
views.
an ID number. If you want to execute different code on different virtual users, then each have an ID number that they can query, so they know who they are.
Yep. Good. So a very quick intro to CircleCI. CircleCI is a SaaS service. So it's a fully managed CI service. You connect it to your GitHub account or your Bitbucket account, and you choose which repositories you want to watch, which means that CircleCI will react whenever you push a commit or when you create a pull request. And then it will run through, it will clone your repository, look for a configuration file called config.yml. So same as Travis, and same as I believe Jenkins has nowadays with the Jenkins file. Anyone uses Jenkins? And the configuration file basically specifies how each phase should be handled. So how it should pull in dependencies, how it should build your app, how it should test your app, how it should deploy your app. And yeah, I guess that's the short version. We can have. So I've pre-prepared this again. There is a repository with this Circle file and with this load test script that we've kind of created now together here. And this has been connected to CircleCI. I will show this is what the CircleYML file looks like. So this is a very, very simple config file. All it does really is make sure that K6 is downloaded and installed in the environment. That's what this step does here, all this code. And then the main step here is using this binary to run the load test file, which is located in the load tests folder in the root. Good. Let's commit something so we can trigger a build. Let's see what the main script looks like. Good. Let's see if we have any changes. Yes. Good. There we go. There we go. Let's push it. Go back to CircleCI. You can see we have a running build here. Let's go there. And let's follow along. Yeah, so first is doing some pre-preparation of the environment, doing CircleCI stuff. Setting up some environment variables. Yeah, so it's restoring. So I've run this previously, so it's already, the K6 binary is already cached in the system, so just restore it so we don't have to fetch it again. Cloning repository. soon the interesting part. Can we have some thunder? No. Here we go. here's the execution case 6. So it's very similar to how it looks like in my local environment. But yeah, the output is not as pretty in terms of the progress. This is 15 seconds. And yes. So here we can see the results. It's very similar. So all the checks passed, but we have a threshold that failed. So that failed the build step. That's what this red thing here indicates. So the previous ones had green. This one got a red one. So this actually fails the build. So if I would have had like a deployment step in my config after this, that would not have happened. I mean, the deployment step, the failure would have happened, but this would have prevented it. So like any CI build really. Yeah, I don't think I have to explain how that works to this crowd. Let's fix this. Let's increase the threshold 100 milliseconds. Oops. That's fine. Push. Bad network today. Anyways, so what this would have done would basically fix the threshold so that it would pass the build. And yeah, I'd set up also CircleCI to send notifications to Slack, which is the tool that we use internally for getting feedback like this. So here we can see that this failed. So I would then just go to CircleCI like any other CI tool and have a look at why. Yeah, let's keep this. So this basically then concludes the demo portion of this. So let's go back and summarize. So the core beliefs that we started out with and kind of explain why, and then showed a little bit how now with this demo is that developers should be running more load tests. For that to happen, developer ergonomics is very, very important. So the tools should support how developers work. And we believe that simple tests are better than no tests. So, focus on getting something up and running, and then after that, you can worry about getting it all realistic and perfect. Tests should be goal-oriented. If you don't have goals, you can't set up thresholds, which means your test can't pass or fail, which means you can't run it continuously or automated, as it won't run in a CI environment. And lastly, the tool that you use should support all this. That's it. Any questions?